The Essential Education projector range from Hitachi sponsors ICT programs.
Coming up in today's programme, a maths teacher gets a crash course in control systems. We visit a Year 10 class in Cambourne who are using handheld technology to produce striking 3D scans. And we've got more top tips.
When pupils are using the internet to find information, always try and select some websites first. It's amazing how much time pupils can waste searching the internet and not finding the information you'd like them to.
Hello and welcome to ICT SOS. Lucy Foster is a maths teacher by trade, but has been asked to teach an ICT module in control to her Year 7 class, and she'd like some help. So what's the problem?
I've got a Year 7 mixed ability class and I need to teach them about control systems. The problem is it's a little bit dry, so I want to find something that's going to make it less boring for them.
Rob Petch is an AST in ICT. He's an expert in control technology and has brought along a little friend to give Lucy a helping hand.
I'm going to show her how to use a little robot model and some free software in order to make this whole thing a lot more exciting.
Rob's built a robot from a kit which has small motors that turn its 6 wheels. But how does it know where it's going?
It's a bit like when you use your TV remote control. You know, and you press your remote control, it sends out a little beam of infrared light, and it's got 3 little senders or emitters just here on the front. And if it sends out a beam and it hits an obstacle, it's going to bounce back and the sensor's going to pick it up. And that tells the brain to sort of turn away from where the obstacle is. And that's how it finds its way around.
Okay.
So it
Sounds good.
sounds pretty clever, but it's about as intelligent as a slug or something like that, really, you know. Let's try it. There it goes. Then if you... That's it. So you can actually steer it. Yeah. So it's a lot of fun with the kids doing this, but you have to be pretty quick.
Yeah, right. Catch it before it goes off the edge.
Yeah.
So how could I use this robot to introduce control to the class then?
Well, I think rather than just saying, right, here's a robot, this is working through control technology, actually start them off with a few questions.
Okay.
To actually get them thinking about it. I thought what we could do, we could probably use some of the tables over there, put them together, put some boxes on the table to make a simple maze,
Yeah.
and then see how it would navigate around the maze. We could then get them designing their own maze,
All right.
yeah, using a painting package, yeah, and then what we can do with that picture that they've created is import it into another package which is easily available off the internet.
Rob shows Lucy how to use paint software to draw a basic maze, which he then imports into Logo, one of the many free pieces of control software available on the internet.
Yeah, they're going to do it on a desktop machine, so it's going to be a bit easier.
Using a variety of commands for direction and distance, the pupils will be able to navigate an icon, known as a screen turtle, around their own maze. Amazing.
And obviously, whilst they're doing that, they're going to learn about how accurate you have to put your commands in.
Yeah.
Yeah. So get that precision concept across.
All right, well, that's great. Thanks very much for showing me that.
You're welcome.
I'll look forward to trying it with the students and we'll see how it goes. Right, make sure you've got bags off tables.
Once in the ICT suite, with Rob watching on, Lucy begins the lesson by linking the concepts of control with the real-life examples of the Mars rover.
And why doesn't it bump into things?
Because it senses when it gets near to something.
That's right, okay. So it's using all sorts of different control features.
After the introduction, it's time to introduce Rob's robot.
We've got something else on there to stop us bumping into things, which is our sensors, okay. So we're going to set it off and see how it goes.
It's got the little robot buggy on the table here, and that's moving around, and you can see from the attention the kids are giving it, it's really bringing this to life for them. What I like about this is that's cost us £20 to use that buggy rather than £2 billion that the Mars rover costs. Yet it's actually bringing across the same concepts for the children.
What did you notice about the way it moved?
Because the sensors picked up all the bumps in the table.
Yeah, we've seen that it's acting on the information it receives from its sensors. You're going to go and have a go at doing your own one now, okay?
As the lesson moves on, the pupils draw their own mazes that the screen turtle will later navigate.
I reckon what we should do is when we make a start, we should make it go separate into two ways and one's blocked. Yeah.
Lucy's got the students using the painting software now. What's nice about that software is that none of the students have a learning curve for using it because they've probably been using something like that on their computers at home.
Right, now go down to MS screen and then click bitmap, click load and then click on it again. Because now
Using the familiar painting software gives the pupils the opportunity to work quickly and even to personalise their work.
Oh, so it's for you two. That's really nice, Holly and Kerry, H&K. Brilliant.
Once the pupils have saved their designs, Lucy shows them how to import their work into the control software. She explains the basic commands they need to enable them to navigate the screen turtle through the mazes.
Where do you think I should go first with this? 50. Oh, 250. What do we reckon?
50.
I'm going to go for 70. That's sort of in between. Yes. Okay, right. What's going to happen next? What's the next thing I need to do, Tom?
LT90.
LT90. What's that going to make it do?
Turn 90 degrees to the left.
Fantastic.
Right, forward 100. 30, 70. Down it, back. 40.
Watching the students working together here, there's some really nice collaborative work going on. And listening to them, they're not just chattering, they're actually doing some analytical talk there to work out what distances to program into the thing to get it to move around the maze.
Yeah, so we can get back down again. Okay. Left, 90.
By using the command programming software here, students can actually learn in a very practical way how precise you have to be in framing your commands. Because if you don't frame your commands right, you're going to run off the maze.
It's gone forward 5. It started off at the edge and it's gone 5 forward. Look, there it is.
Okay, so if we go left, then we can start here instead of going right down.
Right, turn your monitors off, please. You've shown that you can use your own control commands to program your own robot, as it were. So well done. The robot, in particular, the children found very exciting and interesting.
Although it was just a cheap thing, it really engaged all the kids. I suppose it's because they tend to empathise with these things. It's like a small animal or something, isn't it? And you know, that made it a lot more fun for them.
The programming that they did themselves, drawing the maze and using the command controls to get around it, gave them an element of using control in a way that they could access and learn from.
By using the robot and the picture of the Mars rover, the pupils were able to make the link between control in the classroom and control in the outside world. Don't forget, you can find out information about the resources that we saw Lucy and Rob using, or anything else in the programme, by visiting the Teachers TV website. And now for some more top tips.
A top tip is buy webcams, not video cameras. They're much cheaper and much simpler.
My top tip is at the planning stage, think, is ICT really going to enhance this lesson?
As an alternative to an interactive whiteboard, why not try one of these wireless tablets? They offer all the functionality, even more flexibility, and a third of the cost.
Finally today, science. Pupils often think that schools lag behind the outside world when it comes to using technology, but science teacher Nigel Bispam wants to change all that. He's been teaching waves and radiation to his Year 10 pupils, and he's been producing results similar to those found in hospital ultrasound scans, but using much cheaper equipment. Here's how he did it. Today the subject is ultrasound, and Nigel has found a brilliant way of using ICT to teach it.
It's underpinned by one of these little beasties, which most departments have got in some shape or form, and they're either called motion sensors or rangers, but as luck would have it, they work using ultrasound. They've got a transmitter in there that sends out a beam of ultrasound, reflects back off an object and records the distance for you, which is absolutely perfect for this activity.
Using the motion sensors, PDAs and a spreadsheet package, his pupils are going to produce a 3D ultrasound image of objects hidden in womb-like boxes Nigel has made in advance.
If I was to take this over to the window, what would that be? A womb with a view. God, it's... Right. I'm sure they'll be able to edit that out, so don't worry about that. My main priority is to get the ICT into the pupils' hands as soon as possible. The great thing about this is there's nothing lost if they make a mistake. I'd much rather have a risk culture in the classroom where they try something and it doesn't work, because they're going to learn a lot more from that.
The pupils take depth readings at measured intervals across a grid on top of the box. A picture of what is in the box is gradually built up from the variations in the readings.
Might be.
The data is displayed on the PDA and pupils then record their results on a spreadsheet.
Is it on A4 now? Yeah. 0.549. 0.8280.
They're actually going to be able to create a three-dimensional image of an object that they can't see. They do tend to think schools are miles behind in technology. So the empowering that they can actually do something first, I think, is psychologically really brilliant.
550.
To turn the data into something more meaningful, the class experiment with some of the chart options and produce 3D ultrasound scans of the contents of the box.
When you've got low readings here, what was that telling you?
There's something, yeah.
There's something high.
Something, yeah, because you get a lower reading, so there's less distance between the sensor and an object.
Brilliant. The challenge I want to give them is how can you turn just a bland set of data into a really creative image, and I'm hoping that's when their intuition is going to kick in and they'll find different ways of doing that.
The small readings we need to make into big readings, and the big readings we need to make into small readings. Is that right?
Why don't you do 556, take away the number, and that will give you what you need.
Nigel suggests they use the 3D bar option, but as often happens with ICT, the pupils know better.
Where did you get that from? How did you get that up? What's this chart option called?
That's just surface on it.
What made you choose that one?
Well, you can just smooth it all out.
3D, see it better.
Yeah. Okay, guys, I stand corrected. It's good.
We've got to turn it inside out, really, haven't we? Yeah.
You can now open the box up and see how accurate your data was. The magic moment, fingers crossed, of this lesson is that they create this three-dimensional image, but then they lift up the box and they look inside and they finally see, is that what they've got? That should really be the icing on the cake.
How fun will we try? Oh, I thought it was going to be a baby.
How many different heights you got?
Looks like 3.
It's excellent. So you've got your 3 heights. Very impressive. Well done, guys. You've got it. You've got it. That is absolutely fantastic. So you weren't sure whether you got the 3 heights, but you have. And the absolute joy of this 3D stuff is you can keep turning it around, looking at it from every angle. Excellent. I think they really understand ultrasound now. They've processed and analysed the information. And furthermore, they've created an image for themselves, which normally would, need tens of thousands of pounds worth of stuff in a hospital to do. In fact, they've got ahead of hospitals now because they've created a 3D image that hospitals, as yet, don't commonly do.
What a simple idea made into a really effective lesson. Don't forget, you can find out information about anything you've seen in this programme, or indeed the series, by visiting the Teachers TV website. And I'll see you next time.
Essential education projectors from Hitachi sponsor ICT programs.